The trick to determining this limit, especially when we have a limit where we're going out to infinity or negative infinity, is if I've got a rational function, so a polynomial over another polynomial, what I'm going to do is I'm going to rewrite the polynomial on the inside. Okay, so I'm going to rewrite this like this. We'll have the limit as x approaches infinity of, and I'm going to divide everything by the highest power. And so this is going to be 2 plus 1 over x squared, and then 3 plus 2 over x squared. Now what lets me do that is by dividing everything by x squared. X squared is just a number, and I know that I'm not dividing by 0 because I'm looking at x as it approaches infinity. So x squared, as at least, we can make it at least larger than 1 or whatever it has to be, but as x goes to infinity, certainly x squared is not 0, so we can divide through by it. And now, as the limit as x approaches infinity of these pieces, this is equal to, or this gives us the following: the limit as x approaches infinity of the number 2 plus the limit as x approaches infinity of 1 over x squared over the limit as x approaches infinity of 3 plus the limit as x approaches infinity of 2 over x squared. Now as x goes to infinity of just a number 2, well, x doesn't play a role here, right? Because there's no x, it's just 2, so that's equal to 2. Now if you think about the function 1 over x squared, as x becomes increasingly large in the positive direction, this guy gets really big, and I'm taking 1 and dividing it by a really big number, and so that goes to 0. Same thing down here. I get 3 plus, now 2 over a really big number, that's still 0. And so this is going to be a value of 2/3. Now we've done the same thing when we talked about rational functions in, let's say, college algebra 13, 14, or even pre-calculus. We said if the two highest powers match, then we take the ratio of the coefficients. So we'd have 2 over 3. Essentially what we're looking for here is a horizontal asymptote in the positive direction. Okay, and so that's where we get this 2/3 from.